My name is Markus Hjort. I work in a company called Hjort Technologies, small startup company doing mobile motion technology. Before that, I used to work in a company called Reaktor for 11 years, so I know a bunch of people pretty well here, and I've been here in this stage pretty often, I would say. Anyway, as title says, I'm not talking about anything related to reagent, but for something better, like the backend side, these shitty APIs that were mentioned here. So, but I want to also know a bit of your familiarity with Clojure. This is questionnaire from Clojure survey that is sent out every year for Clojure community to answer. So if I would ask this question here, how many of you would categorize you as a Clojure user who use it for your studies? Nobody. So what about I'm just tinkering? Okay, quite a few. And then I used for serious hobby projects, whatever it means compared to. Okay, you're the serious guy. Okay. What about who use it for real work products? Okay, I think we have a pretty much similar situation here that was in this survey too. I think this survey was I think it has been around at least 7 years, and if you look back 7 years ago, I think most of the Clojure users were just tinkering or using it for the serious hobby projects. But nowadays, people really do Clojure in real work situations, and that's something that I will be talking today too. I remember, I think I was first doing some Clojure 2008 in some Reaktor code camp, but my real work career started 2013, and since then I've been mainly involved doing all kinds of backend stuff with Clojure. I have done some tinkering stuff with Clojure Script, but mostly what I've been doing is microservices style backends, and there are two I would say big cases. I was working for Yle for 2 years, where we were building Yle API layer, which is still, I think the project is still going there, and they are building more and more services. The idea in there is that all the new Yle applications, if you think about Arena, news sites and what have you, are nowadays, those web applications, mobile applications are built on top of these APIs. And then in Hjort, I've also been building back of course also front end, but I would say mainly backend stuff for our services. In both of these cases, it has been polyglot, and in both of the cases, the reason for using different kind of technologies is just that the history, it started like that. So when I went to Yle, there were also already stuff built in Scala and Node.js. There were many teams building stuff, and every team has an opportunity to choose their own technology, basically. And the team I was in, we started building stuff with Clojure, and later on, I would say nowadays most of the stuff there is built in Clojure. I don't know exact situation now, but I would say that at least for new services, the Clojure is the de facto. And in Hjort, we have a bit similar history that as startup companies pretty often they start with either Ruby on Rails or Node.js, and this time it was basically there were few monolithic applications built on Ruby on Rails very fast, and now last 2 years we've been trying to convert performance critical parts to Clojure, and then building new services with Clojure. In both of these cases, it has been a DevOps style stuff, so we have been responsible for building and maintaining and monitoring and installing and profiling and all that stuff related to these services. Yeah, that's my work experience, and what I'm now going to talk about, this is like from the trenches, though. So now, like after this experience, I'd like to share just how we have used the Clojure, what kind of decisions we have been making. That like, okay, we use Clojure in this way. I try to give some reasons why we chose like that, but of course it's often context specific. So the first thing, so why we chose JVM, because as was in the slides, it has been in both of these cases all the services have been built in JVM, not Clojure Script. One thing is that this is a pretty actually old feature. There are like quite a lot of Java libraries, and to be honest, if you look at their like npm, there's actually even more JavaScript libraries. And as in previous talk, you're saying that it's actually pretty easy to use JavaScript libraries. But I would say there are no metrics, but for backend stuff, I would say that in Java, most of the libraries in GitHub are for backend technologies. And in JavaScript side, it's other way around. For example, we are now using GeoIP database, where like we take IP address and try to find where the people are coming from. And there is the integration Java APIs for doing that, but no JavaScript libraries. So there are a lot of backend related technologies where there are no JavaScript libraries. So in that sense, for backend, that's at least for us, it has been a good choice to use JVM. And then, yeah, I think this is pretty much actually the same as in Clojure Script, that it's really easy to use most of the Java libraries, not frameworks. That's awful. But using Java libraries from Clojure, I think it's nicer than using them from Java itself. So that's my experience, at least. It's very concise, the syntax and so on. Another thing, in both of these places where I've been, I would say that the domain has been pretty complex, not complex like this Opetus Holitus case, but more the problem has been that either the service has a lot of users, so there's a lot of requests per second, and then that's why the performance and scaling is important, or then the service itself is doing something really heavy that we need performance otherwise. Like in Agile, we are doing a lot of lots of different kind of media processing. Like we take in font file and we subset the font file. We take in images and we convert them in some way. So all of these services require performance, and then that's one reason which is super awesome that JVM has really good tools for monitoring and profiling and what have you. And comparing now the Clojure Script side, we actually do use these Clojure's parallel processing stuff pretty often to improve the performance. Just like as example, this PMAP is pretty often used. You very easily can run your algorithm in parallel, which speeds them up. Or then the reducers library, where which utilizes the Java's fork join, which is in a way even more effective for parallelizing your computation. So there are like a bunch of reasons for choosing the JVM, and of course these are just excuses. This is the real reason. So like at least in both cases there have been, like me, bunch of people who have been doing the just old JVM for quite a long time, and you don't get fired if you choose the JVM. So that's to be honest. Okay. So then how have we been running the Clojure code? There have been two options. Either just using the when we were in Yle, we were not using cloud services. Instead, they were like good old hardware inside Pasila, and then there were virtual servers on top of that, and then our job was to install stuff there. And we used just package the Clojure code as Ubercharge, and you used both HTTP Kit or Jetty for like HTTP routing stuff. And I think now in Adtal we actually have also one this old-fashioned way of service still. And then in Adtal, most of our services we are running them in Amazon using Lambda functions, where we just deploy. It's a Uberchar. We deploy it, and then this Lambda service actually will invoke the function when somebody comes in. So this is the like default way how we run the stuff now in Adtal. There are some corner cases where this is not the best option for us, and then we can use this normal virtual server option, but this is most often used in our cases. How do we select the libraries we use? This is like I was thinking that like we haven't said this aloud, but I think we have this kind of priority list. So in Clojure, it is actually most often the stuff that you need is in a Clojure core, and this we have been following this pretty heavily. This that if like for example anything related, if you just want to process data, Clojure core has really good and performance stuff for doing that. So that like should be always the first option. So instead of like if you have been wondering how do you do that, then you might ask your like colleague that is there a Clojure way for doing that instead of taking in another library. Number two is use native Clojure libraries like Ring, Hiccup. There's a lot of others. What I mean native libraries that are written in Clojure and which don't depend on other stuff. Typically, number three, there's Clojure libraries with minimal dependencies, like HTTP Kit. It's a lightweight server and client, which is partly written in Java and partly in Clojure. So it's not native, but still it doesn't have dependencies to many stuff, which is nice. The only problem is that at the moment the project is not in that good shape, like in that sense that the original developer, for example, is not really working with the project anymore. But still it has very good stuff in it, and at least for us it hasn't been a problem to use it in production. At least the server is running in production. Then the number four. It's nice that like there are a lot of like simple wrappers, like CLJ, HTTP, CLJ time for like these de facto Java APIs, and it's pretty easy to use them. The reason why this is priority number four, you can see it from here. This is, for example, CLJ HTTP dependencies. So when you take in this wrapper, you take, which uses the Java library. You also take the Java dependency hell with you. So I don't know what's the size of this, but you get like a lot of libraries, and then you get one logging library. And if you take another, go on.
Anyway, I have written a tool that displays the size of each dependency and summarizes it for you.
Okay, I don't want to see it in this case, maybe. But yeah, that's a good point. Yeah. Sometimes that would be good because in those AWS Lambda functions, we actually really care about the size of the Uberchar because there is a limit of 50 megabytes for the service. So So really, if you use a lot of these Java APIs, then 50 megabytes is not that much. So this is something that's the reason we haven't been. We tried to. If there is a better like native libraries, it's better to use them. But again, like the problem is that I would say that there still many of the Java APIs have more features, and there's like these wrappers, like you get the new features faster often. So then priority number 5, I would say, then is just use Java APIs directly. No wrappers, nothing like that. And this example a very good case that like we are using a lot of AVS services, and there is actually de facto Clojure library for that, which is Amazonica, which is a comprehensive client for the entire Amazon AVS API. So if you take this in, it's like 35 megabytes. You can then start excluding stuff and so on, but and then this library is using heavily reflection and what have you and so on. So in this case, we decided to use just Java API directly, so that because we need like, even though we are using a lot of AVS, we still probably use only 2% of the Amazon's like functionality, and it's hard to nobody like to use everything from AVS. So this is like typically the last resort to go to directly to Java APIs. About testing, how do we test Clojure code? Again, simplicity. We'll be using this awesome framework for testing, Clojure.test, which, like, at least for us, it has worked very well. It doesn't have that much features, but again, it's like, at least for us, it's in every service. Like, nobody knows how to use it, and it's easy to extend. It doesn't do a lot of macro magic like the Midge, for example, using. So at least in our purposes, it has been like just good enough. And for the stubbing, we don't use again any libraries, but instead just with redefs, which comes with Clojure Core. I don't know if you're just familiar, but with redefs in a test, you can just like redefine the function with some other function. So here, for example, uploading the S3, it's inside this test, it's redefined as a function which will throw an exception in this case. And we like this is easy because we are just redefining the functions. I know some people do some Clojure protocols and what have you to separate the functions that you want to override, and there are then some mocking libraries that like somehow use those protocols, but at least I think this has been a lot simpler way to do things. And so okay, this is actually especially was a question in Yle, maybe, because there were a lot of stuff written in Scala, which you might say that it's pretty strongly typed language, and which Clojure is not. And then this is the argument that often comes: how do you maintain large code bases without types? And then, at least in these cases, the answer is that we don't. The thing is that the decision to use only microservices, there are like also, I don't go into detail what are the drawbacks with microservices, but at least one good thing with microservices is that you don't end up having large code bases. So I remember like when I was in Yle, the biggest services were like some thousands lines of code, and now with this Lambda function stuff, we are talking about hundreds of lines per one service. So I would say like it's not that a big deal to refactor that stuff. Instead, there is a problem of having a huge number of services. And then I would say that the problem that if you want to use types, the sad thing is that you won't be using Clojure, because there is this typed Clojure, which is an optional type system for Clojure, but it's not very mature, and how the things being going, it's still a one-man's project. There are some interesting stuff there, but even I can't pronounce the name of the guy. It's a French name, but anyway, the guy, like, he's doing very good job, but still the problem is that he's also saying that this will like never fly in that way, that it will cover all the Clojure core libraries and things like that. So you have to live without type system with Clojure, and instead, at least in these microservices, I think it's more important that you validate the input and output of your microservices, and you do it actually that you can be you should be doing it in the runtime. Of course, if there would be a option to do it otherwise, maybe it's good, but in runtime, because in both of these cases, it's impossible to run the whole system in your computer anyway, so you cannot check the whole system, but then just run it, and then we'll be using prismatic schema for a lot for validating those inputs. When we started in Yle, we were not doing this, and I think we had a lot of problems with this. And I think nowadays in Attal we have been more strict with this, that we actually do this stuff. Okay. How do we manage state in Clojure? When I was first reading about Clojure, I think one of the key selling points, at least Reaktor, in Reaktor people were saying that nowadays there's a new cool language on top of JVM that can run that has the software transactional memory, and there's this kind of cool stuff. Now being doing Clojure for quite a long time, the only state management functionality from Clojure what I've used is atoms, and typically if you talk about service is atom. So that's the only state management stuff that you typically need, at least in our case. So this is one API, and this is all the state handling code that is in this. There is one atom adds, which is a initially empty map, and then there's a function update state, which will be called I think once a minute, which will read from the database all the live adds and then resets the atom, and that's the state handling for this whole API. And this atom, I don't know, at least it hasn't been the performance bottleneck. We've been testing this with small machines and with 1,000 requests per second for a machine, and it's not a problem to always reset the whole atom with quite a lot of data actually. So it's no-brainer. So, as a takeaway, what I've learned is that the Clojure is an opinionated language, and I think it has been a very good thing. In both of these cases, there were not that many people who were familiar with Clojure beforehand. I would say that one or two people, and then after that there has been a lot of people doing Clojure, and people learn the Clojure pretty fast. And one of the reasons is that the Clojure itself, for example, then when in Yle we were doing their Clojure and Scala, it's very easy to learn the Clojure because it's very opinionated. There are not that many ways for doing things, and I think which has also helped that we have been opinionated too. So what I was like showing you today, it's also one thing that I think it's good to be opinionated too. Like let's use some simple libraries and so on. It has many good benefits if you want to succeed like in the long term with, I would say, with a lot of people working on same code base. Okay, that's all.